first question is classify. The figures has been given and you have to classify out of this that which are simple curve. Okay, out of these all these curves, which are simple curves. What are simple curves? First is simple curve is a curve, okay, which get completed without lifting the pencil or a pen. Okay, for example, if I start for this curve, if I start from here, okay, and you can see that I can complete this curve without lifting my pen. Okay, so this is a simple curve. This is closed curve also. Why? Because it is closed, there is no open space among these boundaries. So I can say that this is simple as well as closed curve. Okay, now let us move here. If I start from here and draw this, so this is a simple because it is not cutting anywhere or crossing anywhere, and this is closed because it is not open anywhere. Third, okay, firstly when I draw this, you'll say that yeah, this is a curve. Okay, this is a curve and this is a closed curve. But to draw the second one, to draw this second one, I have to lift my pen. So I can't say that this figure is not a curve, not a simple curve and not a closed curve. Why? If it would have only a circle, then it would have been a closed curve. But here there are two circles, and you have read it or you have learnt that simple curve is a curve or plain curve is a curve which can be drawn without lifting the pen. And to draw this figure, I have to lift the pen from here. Okay, so this is not a simple curve and this is not a closed curve. Now let us move here. Here it will say that if I'll start from here, this and this and this. Okay, you'll say that yeah, you don't have to lift your pen, it's okay. But here you can see that when I move from here to here, then again I go to here, and then again I go to here, and again I go to here. What happens that I am retracing these points. Okay, so from here I can conclude that this is also not a curve, simple. This is not a simple curve because retracing is being done here, okay, to complete this figure. Right, now let us move towards this figure. If I start from here and I have completed it back without lifting my pen and without retracing or cutting the figure, and this is closed also. Okay, so this is a simple curve and this is a closed curve. And here again you can see that if I'll start from here and again without lifting my pen, I can draw this figure, and this is closed, so this is a simple and closed curve. Similarly, if I'll start from here and draw this, okay, again you can see that this is simple as well as closed curve. Now let us move towards here. If I'll start from here, okay, now what I have to do, if I'll start from here and here, okay, and here, what are you saying? What can you see? That I have to go from this point to this point, and again to draw this point, again I am retracing this point here. Okay, so or you can say that this is cutting, there is a cutting, this line is cutting these curves, so this is not a closed curve, simple closed curve. Okay, second, this is not closed, you can say that open from here, so this is not a curve and this is not a closed curve. Okay, so the which are among these, which figures are the simple curves? That was first. Okay, first was the simple curve, second was the simple curve, third was not because I have to lift my pen here. Okay, now fourth is also not because this is not a simple curve because it is retracing is being done here. These are cutting, the sides are cutting each other. Okay, now here you can see that 5 and 6 and 7. Okay, so these are simple curves. And closed, among these, see which curves are closed. You can see that one, okay, one is closed. Simple curve, already they are simple, but one is closed. Okay, second curve is also closed. Okay, and all these curves were closed. Okay, so 1, 2, 5, 6 and 7, all these are closed curves. Now polygon. What was the simple recall the definitions for polygon? Polygons, what were the polygons? Polygons are the simple closed curves which are made up of the line segments. So only two figures are there which are made up of line segments. Okay, others you'll say that this figure is also made up of line segment, but you can see that there are two curves also, so this is not a polygon. Okay, because the polygon is made up of only line segments, no curve. Okay, so the polygon is 1 and 2. Next is convex polygon. Convex means there are two definitions of convex polygon. First is that its diagonal should lie inside the figure. From here you can conclude that when you join the vertices of opposite or non-consecutive vertices or opposite vertices of this figure, that all the diagonals are inside the figure. So this is a convex polygon. Okay, or you can say that all the angles are less than what, 180. Okay, now here you can see that this angle is what, reflex angle. You can see this is more than 180. First thing which is making this a concave. And second is, if this is first, second, third, this the consecutive vertices is this, and third, when I add these two vertices, non-consecutive vertices, this diagonal is outside the figure, so this is a concave polygon. Okay, so in this way I have explained why these figures are closed, why these are simple closed, and why these are concave polygon, and why these are convex polygons. Okay, now let us move towards the second question. And second question is, how many diagonals does each of the following have? It's a very simple. Convex quadrilateral means you can take any quadrilateral where the diagonals should exist inside the figure, and from here I have taken the rectangle, and how many diagonals it can have? Okay, opposite vertices. So I can see that only two diagonals can be drawn here, and which are two diagonals, AD and BC. Okay, these are the diagonals, so the number of diagonals will be 2, right? These are very simple questions. Now let us move towards the B part, regular hexagon. Here you can see that this hexagon is made up of two quadrilateral. Okay, firstly when I join this diagonal, so this will be the first diagonal. I'll write it BE. Okay, and second will be AE, right? AE, BE and AE, and third will be BF. Okay, B and F, right? Fourth, similarly fourth will be BD. So BD, I'm drawing this by hand, but use scale for this. Okay, and next will be what? CE. So CE. And what could be the others? Others could be that 1, 2, 3, 4, 5. Okay, 5 diagonals has already been drawn. Now this is 6, F and D. Okay, and this is 7, right? 7, and what could be the others? 7, 7, AE, BF, BD, and I have drawn the different. Okay, first was this one, second I have drawn this also, third is this one, okay, and fourth is from here to here. Okay, so I can also draw that here to here. right? So this is AD. Okay, and next was from here to here, so CF. Okay, I can take CF. Okay, and next was from here to here, so from here to here I have already drawn. So I can see that how many are there. 1 2 3 4 5 6 7. 2 has been left. This has been drawn. Okay, and this also been drawn. Okay, and next was these two. Okay, and these two has already been drawn, and now these two, yeah, that has already been drawn. So 9, all these 9s has been drawn. Okay, so one was this BE. Okay, second was what? Second was FD. Okay, I have not written it. FD and AC. So how many? 1 2 3 4 5 6 7 8 9. So there are 9 diagonals. Okay, and from this figure you can conclude that diagonal means what? The lines that join the opposite vertices or non-consecutive vertices. You can see that all these vertices are consecutive, that means one after one. So we can see that there are no non-consecutive vertices in a triangle, so number of diagonals in a triangle are 0. Okay, that's all.